Hello everyone, how's everybody doing? I hope you're doing fine. Looks like I'm not sick. I think I am not. I got a little raspy throat, but other than that, I think I'm okay. I hope you are just as well, as good as I am. One more time, I'd like to notify people that we've uploaded a book, and you can go to this site, ropehypothesis.com, and if you click on books, you'll find that there's a book that you can download there for free, and it'll bring you up to speed on the rope model of light, which is one of the things that we talk about here. Okay? And for those of you who have a second language, you can contact us at tokakaka@hotmail.com if you want to translate the book to your native language. Okay. Okay. So how is everyone doing out there with coronavirus? I guess most people are stuck in the world, are stuck within their homes right now. And here in Hessen, we had a little accident. We had a fellow, he's the economic minister of Hessen, of the province or the state of Hessen. And he committed suicide the other day. He's the Minister of Economics, I think he was. And so that doesn't bode well for what's coming, for what I'm suggesting is going to be the extinction of man. I don't know how long it's going to last. Maybe this is the beginning. Maybe it's years away. Who knows? All I can give you not is a timetable. What I can give you is a mechanism. That's what I do here. Okay, mechanism of extinction is through economics, no doubt about it in my mind at least. And yeah, here you have what some cities around the world look like. This is in Argentina, Buenos Aires. We were there last time for the conference, about a block from that building on the right, lower right. The Abasto Mall, and we were a block away from there. You can see it's empty. Usually this has gazillions of people, and it's the same street at night, farther down on the other side of, well, far away, so, about a mile away over here on the upper left. And you can see at night and day, it's completely empty. And this street known as avenue, known as Corrientes, is known as the street that never sleeps. Well, now it's sleeping. And you'll see this everywhere. I mean, New York, even here in Frankfurt in general, they haven't imposed a curfew yet over here. It's voluntary, but since people are pretty much staying at home, it's like they're not gonna need to enforce anything here yet. At least it seems that way. But in Bavaria in the south, oh yeah, they've got the Gestapo stopping you, and they've got the shoot stuff, the whole works. All the police is on the beat. This is in India. They're doing fine. They're practicing for the cricket championship. Using people as sparring partners. Then they do a lot of exercises over there, getting to be healthy people, and that's pretty good. It's good for the country, I guess, right? Everybody's doing exercise over there. So yeah, I guess this brings new behaviors, and there's going to be lots of new behaviors. You're going to have a lot of the companies, like you have a company like Amazon, which is a behemoth, gigantic company, and they're probably going to turn out to be okay with this, because a lot of people are going to be ordering stuff through the internet, and they're just going to get more used to that, and that might have an effect on just shopping. People will not go out so much to do shopping. They'll do all the shopping or more of it through the internet, and that's got to cause a lot of unemployment. That's what I can tell you. Okay. So yeah, there's going to be changes in the next few months, and it's going to be quite interesting to see what kind of changes the politicians impose, right? Among them, the fact that they're giving money out and they're giving tons of money out, and that's also going to lower the real value of the salaries of people who work. And so you got to keep all that in mind, and there's going to be a big impact in the next few months. Who knows if we come out of it? They say 3 months, maybe even up to the year. You know, the last depression lasted 10 years until the war got us out of it. And a war is not going to get us out of this one because, you know, the only thing a war can do is stimulate manufacturing. It cannot stimulate services. So a war would not help us in this case. Okay, just keep all that in mind as well. All the jobs are in services, and those are vanishing, you know, by the minute. There's, 3.3 million people in the United States that already asked for unemployment. That's got to have a big impact. Anyways, let's get on with the subject matter of today. We had a comment by a gentleman who came over, and he says, Scientific Community International, we would love to have you to join us. Please read our description about us, and that's in Facebook. So I went over there and find out, okay, who are these people? What do they do? And this is what I found, okay, Atheist Scientific Community International. The Science Community International, SCI, goes beyond atheism. The meaning of science is knowledge. Sciology. I thought it was sociology and that it was misspelled. No, it's sciology, or sciology, I guess it's pronounced. A scientific philosophy of life and intellectual search for knowledge and rationality. And at the bottom, you know, I looked it up and it said a person who believes more in science and technology rather than God. These people are inclined towards the logical reasoning and deducing events rather than believing in destiny. Okay? We are sciologists, people who view the world from a scientific perspective. Hence, we use logical deductive reasoning that there is a logical explanation for everything, okay? Our aspiration is to use science and technology to help people reach the fulfillment of their lives. Okay, well, I have doubt that these people are scientists. And what gives them away is that first word, atheists. You know, atheists are not scientists. They're religious fanatics. And you might say, well, Bill, maybe you're a Christian or a closeted Christian or Buddhist or whatever. No, I was an atheist for most of my life, okay? And I got out of atheism and got not into theism, not into agnosticism. No, I got into something called science. And science does away with all three of these. And yeah, I've got a long record with atheism and communism. I was a communist for many years, was an atheist for many years. I abandoned both philosophies, both ways of thinking. And, you know, when I was about 13, 14 years old, I was living in Baltimore, Maryland. We were living over there with my family. And we met Madeleine Murray O'Hair, and she was the founder of American Atheists, okay? And we were among the first people who joined American Atheists. We were almost the founding fathers of American Atheists. My folks were, okay? And Madeleine came to our house a couple times. And, you know, it turns out that many years later, you know, I was in Austin, Advanced Micro Devices. My company sent me to Austin, Texas. They transferred me to do some more spying. And while I was there one day, I decided to figure out if there was, you know, an American Atheist branch in Austin, Texas. And it turns out that there was, and it was Madeleine herself. And so about 20, 25 years later, I went to the American Atheists and found these folks. You know, that's Madeleine and her daughter Robin, who was really adopted. She was really the daughter of her son. So she was her granddaughter, and she adopted her as her daughter. And that's John, her son, her second son. Her first one was William, the father of Robin. And I went there, and I met Madeleine 20, 25 years after I had met her for the first time. And I told her that, you know, my fathers had contributed to her struggle She went in there and she got a card. She says, I kept a card from everyone who ever donated money to my cause, and she got a card and it had my father's signature on it. And that was the last time I saw Madeline. A few years later, she was kidnapped together with the other two, and they were murdered. And that's a tragic but interesting story. You can find some of it in the Forensic Files there, episode 10 of season 7. And yeah, it's a very tragic story, but it's an interesting one, what kind of lives they ended up living. It's just interesting. The way I see it, there's no difference between an atheist, a theist, and an agnostic. Okay, all these people belong to religion. Why? Okay, let's find out why. Some people don't want to hear it because they say, oh, I'm an atheist, I'm a rational person, and everyone else is not. And so they don't want to hear the arguments. And they just do themselves a disfavor. You don't have to agree, but it'd be nice to know where the punches are coming from, when you're going to go up in the ring. So it's nice to prepare and know the other side, okay, what objections other people have. And a theist in general, I summarize this, there's all variants and nuances here, okay, but this is just a summary. I believe that God exists. That's essentially the way of thinking of a theist. The atheist says, I know, I don't believe, or whatever. He'll phrase it in a million different ways and defend each one and say that's not belief, and they'll go all over this stuff. Essentially, that's what they say. I know that God does not exist. Okay? The guy feels that there is no God out there. Okay, that's their position. An agnostic wants some kind of proof. He says, well, I'm not convinced yet. I don't have proof yet that God exists, blah, blah, blah. What does a scientist say? A real scientist says, let us assume that God exists. That's got to do with the scientific method that we started at the beginning of this century. Okay, so we have a new paradigm, and we do not respect the scientific, so-called scientific method, the religious method that we've been doing for the last 400 years, since the 17th century so-called scientific revolution. No, that was not a revolution. That was, or maybe it was, but they didn't pursue. They weren't scientists. Okay, a scientist is someone who explains. And these people did not explain. They went on a tangent and they did math, and math can only describe. And all we have today is a bunch of descriptions and irrational explanations. And that's because of the so-called scientific method that all these mathematicians, I call them mathematicians, have followed. Okay? Now, a rational scientist, let us assume that God exists. God can only be an assumption. God cannot be a theory. God cannot be an explanation. God can only be an assumption. And you say, well, let's assume that God exists. And now I'm going to explain how the universe came to be. Here's this guy with a magic wand. He goes abracadabra, he makes the world. Okay, fine. You can go on with a theory. But the point is, God cannot be a theory in himself. God is just an object that you're going to use to found your theory upon, okay, your explanation upon, okay. And whether God exists or not has nothing to do with proving, with eyes, with ears, with touching. No, we don't prove the existence of a chair by touching it, okay. And the way we prove is by defining. We define. Okay, we define what exist means, and no one in the last 10,000 years defined the word exist in a rational manner. That's the whole problem. That's why atheists and theists run around in circles, because no one defined the word exist. And once you define the word exist, all religions die, including atheism. And exist is physical presence. Physical requires an object, presence requires location. God, if God wants to exist, he not only has to be an object, he cannot be love, he cannot be grace, he cannot be intelligence. Those are concepts. No. God has to be an object. God has to have shape. And that's not enough. Squares have shape, but they don't exist. Superman has shape. He doesn't exist. And so God, in addition, has to have location. There's got to be a distance between my chest and his. Then God exists by definition, not because I believe or disbelieve, or because it hasn't been proven, or because I proved it, or whatever. No, it's by definition. things exist by definition. You just have to define the word exist and we're done. Then we know what exists and what doesn't. Or like I like to say, if you want to know if God exists or not, define the word exist. Then you'll know if God exists. Very simple. Okay, what's that got to do with? It's got to do with the scientific method. Here it is in a nutshell. Okay, and as you can see, it's a little different than the nonsense followed by the mathematical physicists, so-called physicists. They have a different version of science, and we have no use for their version of science. It's not science because they ended up with all irrational explanations for how this universe works. They cannot explain a single phenomenon out there in space and down here on Earth. They cannot explain anything at the micro level, at the macro level. They cannot explain gravity, why the Earth doesn't fly out of the sun. They cannot tell you that. They say, well, it's the warpage of space-time. You know, you got the sun weighing down the canvas and forming this depression, and the Earth runs around it like the little ball around a roulette. And that's why the Earth doesn't fly out. Yeah, but it turns out that space-time is a concept, a mathematical concept. Is that what you bent? Is that the depression is in a concept? So we got a big problem with so-called irrational, that's what they are, physical interpretations that mathematical physics offers, okay? Yeah, and so we have 3 steps. The step 1, because we're going to try to explain, that's what science is about, explaining a theory rationally to someone else, okay? A mechanism in the case of physics. And so we need the objects. What objects are going to be the actors in your theory? We need to have precise definitions, especially of the words such as object and exist, those two, motion, things of that nature, words of that nature. And then the initial scene. You need to have a starting point. Every film, because you got to make a film of your theory. You should be able to make a film of a physical theory, of a physical interpretation. And if you're going to make a film, you better put objects there, something with shape. I need to see something. What are you going to put, energy in there? What's energy? What shape does energy have? What shape does a field have? What shape does a wave have? If these are all concepts, dynamic concepts, in fact. So now you need the initial scene. You need to have the first few frames of the film so that you have your starting point for your theory, okay? And then the theory are the mechanisms and causes. That's in a nutshell the most important part. Okay, so yeah, we have a different way of doing science here. That's why it's called rational science. We are only interested in rational explanations for how the universe works. We want to know how the invisible stuff especially works. How does gravity work? How does magnetism work? How does electricity work? This is what we're interested in. And these people have no explanations for that. And that shows the failure of the so-called Newtonian or Galilean scientific method. They're no good. Experiments, math, no use for them. What we need is explanations. We need mechanism. Once we see the mechanism, we understand. Don't give me any math. We don't need any math. Not to understand how Mother Nature runs her shop. Okay. Okay. So let's put this thing back up here so that we can compare them side by side. This is what this group does, and this is what we do, or what the objections we have. Now, atheism is part of religion. We have no use for atheism. Knowledge is part of religion. We have no use whatsoever for knowledge. Knowledge means that you already swallowed something. You swallowed the Kool-Aid. You already know. No one can change your mind. And that's not what we do in science. In science, we explain so that you understand the mechanism just by watching a movie. You know, you want to know how a pulley works? Well, you got a rope tied around a pulley and lifting a box. You pull on the rope and the box goes up. Now you understood just by watching the film. And that's got nothing at all to do with knowledge. Rationality, well, people have to define rational, and people have to define what an explanation is. Have these people defined these terms? Well, I don't know. I doubt they have. So what we do, yeah, we do define these terms, and here they are, okay? We have an explanation, the cause, in the case of physics, reasons, philosophy, underlying a phenomenon. That's what it is. You need, in the case of physics, you need to have a mechanism of how it happened. An explanation deals exclusively with the past. Science deals only with consummated events. Okay, description, that's what math does. It's a listing of physical properties of a physical object. Okay, that's all it is. And they use adjective to describe. That's what. But of course, you won't see that in mathematics, because what mathematics does is it works with motion, things in motion. So their descriptions have to do with phenomena that happened, and what they're doing is describing speed, weight, and these kinds of things. Okay, and the last one, help people, technology. No, we say that we're the last humans on Earth. Okay, so we're the last generation of humans on Earth. So no, don't help people, because in the sense that, I mean, of course you want to help people, but there's no long-term solution for humans. We're the last branch. Not everybody agrees with that. Okay. And you need to become familiarized with the theory again. Not with when, that's astrology. We need to know, we need to understand, okay, what the mechanism is. How did the dinosaurs die? How did Neanderthal die? That's what we need to figure out. And none of these people have figured it out. You got all these geneticists saying that they mated with us, and that's how the Neanderthals disappeared. And the dinosaurs, well, there was a rock that fell on Earth and just killed them, and so on and so forth. All nonsense, absolute nonsense. So, yeah, we need to figure out how these past extinctions occurred, and then extrapolate them to man. And when you do that, well, we have very little chance of surviving what's coming up in the next few months. Okay? Rationality, what is rationality? Well, we have criteria for that as well. So we put it down primarily as that first one. When someone treats a concept as an object, then they're reifying, they're doing concretization. And when they do that, it's quite irrational. Okay, that's the criterion, the primary criterion. You have a couple more using undefined terms or using them inconsistently. Okay, and that the theory doesn't follow from the assumptions. Describing and thinking that you've explained, a lot of that going on in mathematical physics. And then the mechanism proposed doesn't work or cannot be imagined. Space-time, again, because it's a concept, so you cannot even imagine the mechanism because it's not visualizable. You cannot visualize this thing. Okay, squaring the circle there, poor old God trying to square the circle. Okay, so I don't know about these folks who say they're doing science. Okay, they should become acquainted with this side first a little more, so they realize that they're going to crash against a brick wall here. There's going to be, and I make no apologies, I try to be as honest as possible. You may not like what I say, but I'm going to give you a different interpretation of what you see out there. Okay, you don't have to buy it. It's up to you. All I'm saying is before you can come and talk about what science is, saying, well, I don't do religion, I do science. You may be doing religion also, especially if you do mathematical physics. That's pure religion, just nonsense. Okay, here's another fellow. He put a comment. Okay, see if we can move along here. They say the electron orbit is a probability wave without any certain point in location nor direction. So when light enters into a prism, there becomes some interference patterns which slow down the speed of light. Yeah, that's the version of quantum mechanics, but I want to address that first statement, the fact that these people say it's a probability wave. Okay, so what is a probability wave? Let's find out. Okay, here we have it. Definition you'll find out there: probability wave, a quantum state of a particle. I guess they're referring to a corpuscle, right? Or system as characterized by a wave. A wave? What's a wave? There's no physical object called a wave. Wave is a verb. Propagating through space. Through space? We don't travel through space. We travel to the moon. You can't travel through space because space is not a medium. Space is not a physical object. Space is not a container. But all these people treat space as being made of particles or being some kind of container. It contains the ether or who knows what. Space-time. You got all these notions of space, and none of them, what they never did is define the word nothing. That's the problem. They can't define the word nothing, and that's why they made space into something. in which square the magnitude of the wave at any given point corresponds to the probability of finding the particle at that point. Okay, again, what is a wave? It's a disturbance. That's not a physical object, so we can't say that a wave did this or the wave did that. It's not a noun, it's a verb. Particle, it's an excited field. Again, not a noun. Field is a concept, and a concept is not a physical object. What is a field? A physical quantity. Okay, so we have quantities. Okay, let's see what this is. Here we have a field. Let's see if you like my field. It's the field is a bunch of numbers that are vibrating. Big 9 because, you know, it goes from the center outwards. The farther away you go from the center of an object, the weaker is the field, whether it's gravitational, electric, or magnetic. So is that what it is? A bunch of numbers that are vibrating? Is that what a field is? And here's a better image. This comes from these folks. Okay. Here you have a vector field, okay, and you have an electric field. You got all these fields that these people talk about, okay. Is this what we're gonna? Are these the fields that these folks are talking about? Okay, so you got to keep in mind that they're talking about concepts. See what you're staring at, all those engine arrows that you see there. Everywhere you see all those arrows, those are vectors. So what they have is they made a physical object out of a mathematical concept called a vector. They just put a bunch of vectors and they start moving them around. You think they're moving something physical, and they're not. What they're moving is number lines. And people are not aware of that because we're so used to seeing all these things that we take them for granted that, oh, okay, yeah, I see what it is. Yeah, it's a wave. So what is a wave? A wave is a bunch of vectors. And people are not very much aware of that. And that's the problem, okay? So, you know, I try to wise people up on these things because they don't realize what the mathematicians are doing. They're dealing only with concepts, with abstract concepts, introducing them as physical objects. That's the problem. We'll see a couple more here in a minute. What does Wolfram say for this probability wave? Well, it says it's the probability of finding an electron within the volume of an atom. Okay. So what are we talking about? We're just saying that that's what moved the probability wave. Is that the explanation? Is that the physical interpretation? So yeah, you have to look at the language. You have to look at what these people are trying to tell you, and you'll never understand them. They even admit that they don't understand their own theories. And right, they never will, because this is the nonsense that they put forward. They say, well, you know, it's a probability wave that's moving. What the hell is a probability wave? Is it a physical object? I mean, what is it made of? Water or what, you know? Okay, here's another comment along the same lines, okay? And this fellow says, a wave is energy propagating through a medium. For example, the displacement of water by a stone striking a pond. Well, a wave can't be energy because neither wave nor energy are physical objects. And this is the problem. People are talking using word wizardry. That's what they're using. They're moving concepts, and they think they're moving an object. They say, well, a wave is an energy. Well, we don't know what an energy is, let alone a wave. So far we have nothing. We have concept. All you said is that intelligence is the movement of love. Now, what sense does that make? And that's what this is saying here. To say that a wave is energy in motion is the same thing as saying that intelligence is love in motion. You haven't said anything. That's okay for poetry, by the way, you know, but, you know, and here you have a picture of energy, okay? So keep a good eye on it. There you have positive energy and negative energy, okay? So if you ever wanted to know what energy looks like, well, there you have it, okay? And yeah, and it turns into particles, which is empty space, supposedly. That's the version of quantum mechanics. Okay, here's Feynman, who puts you straight if you missed something. Okay, he says, you know, Nobel Prize, by the way. It is important to realize that in physics today we have no knowledge of what energy is. Yeah, whenever they don't understand something, they say, "Oh, energy," and everybody says, "Oh, now I understand." And so that's the world we have today. So yeah, these people are not, they don't understand their own theories because they're using word wizardry to get by. They're saying energy, force, field, time, charge. You know, they have all these fancy words, and they're all concepts. And they want to do physical interpretations with concepts. Yeah. And so here you have, the spirit that we used to have in the old days, and now they call it energy. Okay. So now you know what energy is. It's just a rehashing of the old spirit of traditional religions, right? Okay. Another comment. So we get through the comments here, and this fellow says, I was taught that color was a function of wavelength. And yeah, it is. I mean, if we're going to use the wave, the longer the wave, the redder it is, the shorter the wave, the bluer it is. So here you have it. It's in the spectrum, okay? You can see the spectrum is based, the color spectrum is based on wavelength and also on frequency. Okay, and they're inversely proportional. Okay, and the reason they're inversely proportional is you see it here. Okay, this is the equation: C equals frequency times wavelength. When wavelength goes up, then what happens to frequency? Well, it goes down. They're both inversely proportional. Okay. And so, yeah, wavelength is, a color is a function of wavelength. The problem is that that's not what the quantum people believe. They say that on one side when they're talking about one thing, and then they say something else on another. This is what you should be able to see through a prism. You should see colors coming out. The colors you even see through the prism, but also when they come out. And these people don't say that. They say that, look, when it's going through the prism, the wavelength slows down. Okay, it slows down, and what's slowing down is the speed, they say. And speed is not wavelength, and wavelength is not speed. So keep that in mind. You can't have it both ways. You either talk about speed or you talk about wavelength. And these people have these weird notions. Here's one, which I'm saying that their theory predicts, which is if you have this prism out there in outer space, okay, and you shine a white light in, you'll get the rainbow colors in the prism. But then, since when it comes out, there's nothing to stop it again, it should go back to white light. And that's not what you get. What you get is what you just saw. You get something like this, okay? And the other thing about this is that they got it in reverse. They have violet light or ultraviolet, right? For example, that end of the spectrum. And it's got shorter wavelength but travels slower when we know that it's higher energy. And red light or infrared has the opposite effect. According to quantum mechanics, they say, look, it's a longer wavelength, but it travels faster through the prism. This is their conclusion. Even though red light has lower energy, as they call it, right, than violet light. So they have contradictions everywhere. And they never clarify these things. They just get away with saying these things, and that's it. Okay, just in case, the rope model, there it is. Rope model of light, why we have colors, very straightforward. You have the red atom there, yellow atom, and the blue or purple atom at the bottom. And you can see the red one pumps slower than the blue one, right? And what happens is the wavelength, in other words, the link length in case of the rope model, is longer. And that atom is tied to another atom down the road that's beyond the edges of the frame there, okay? And so it's pumping that frequency and that wavelength to that atom that's down the road. Could be one in the air, okay? And that's essentially how it works. So it's straightforward with the rope model, okay? There's no mystery there whatsoever. Okay, what I want to talk about today specifically were a subject that I left behind quite a bit, about a month ago at least, and that's bringing back the Greeks. Okay, I went to establish where we got some of the geometry that we have today, especially point, line, and plane. And hopefully I get to the plane today. Okay, but anyway, let me rehash some of this. Here we have good old Airy. And he's the guy who came up with this notion of that which has no parts for the word point. And he states also, this is out of his book, okay, by the way, Physics, can have no extremity, the extremity in the thing of which it is the extremity being distinct. In other words, the points at the end of a line, he says, are distinct than the line, okay? And we're going to see this notion also in Euclid's Elements. Okay, he uses these notions. He says a point is that which has no parts, and he says the ends of line are points. Okay, so that all the Greeks around this time were thinking in the same terms. And I'm sure this is not original from Euclid, because Euclid was born the generation after Aristotle, maybe 2 generations away. We don't really know when Euclid was born. Okay, so Euclid studied in Athens. And he probably studied in the other school, in Plato's school, with people who did not agree totally with Aristotle, but they all pretty much had these ideas about what a point is and the definitions and so on, and the fact that points are the ends of a line. Okay, and they use them for different purposes. Aristotle is going to be talking about foundations of physics, or what he wants to. He wants to explain the natural world. He wants to explain how this universe works. So he uses these nouns that you'll see in his book. He talks about location, distance, actually distance traveled, because that's all that math ever did. Motion, time, he uses number also. He uses number. He tries to use numbers to make his case, okay? And Euclid uses something else. You know, he uses other types of nouns because he's going to set the foundations for mathematics or geometry. He uses the point, the line, the plane, things, you know. Aristotle stopped at line because that's all he needed. He didn't need the plane, he didn't need the solid, and he did use the number because he's going to use that as locations along his distances and separations, essentially, okay? So they come from 2 different sides, Euclid from Aristotle. They were trying to accomplish 2 different things, okay? And so how does Euclid define line, okay? Well, he defines it as breathless length, okay? And we got a problem, and right there and then, whether it's the translator or whether it was Euclid himself, I don't know, because it's very hard, unless some Greek knows exactly what that word means, you know. Breathless, breath is a vector, it's not a dimension. And so what this person is saying, that you have this length that extends, I guess, forever, but it has no thickness. That's the breathless part, I guess, that they're trying to convey. So what is a line? I mean, what do we have in front of us? Specifically, how is this related to geometry? Because geometry deals with shapes primarily. You know, first and foremost, you need to have a shape. And not only do we have no shape for the no part point, but we have no shape for the so-called one-dimensional line. And I challenge you, you know, grab a pencil, a chalk, crayon, whatever you need. I want you to draw a one-dimensional anything, okay? Anything. I don't care. These guys say that it's a line, fine, call it a line. I want you to scribble, to write, to draw, illustrate a one-dimensional anything. See, and that's what you get in math. You get a lot of these things like singularities that have no size, no volume, no nothing. It's a zero-dimensional nothing. And they call it a singularity, and that's what the black hole is going to be. And something similar with a line, you know, you've got the string theory, and they use lines. And what is a line? Well, you know, they have these one-dimensional lines, and that's what they're going to construct their theory with. Keep that in mind. That's string theory. That's the new kid in town, you know. Anyways, the ends of the lines are points. Parallel, very interesting issue there, because he says parallel straight lines are straight lines which are straight lines, great, which be in the same plane and being produced indefinitely, meaning infinitely, right? You extend them all the way to kingdom come, right? In both directions, do not meet one another in either direction. And that's essentially the definition we have today. So what is Euclid saying? That I got to go all the way to infinity to find out if these two lines are parallel? I have to run an experiment. I have to walk or run, maybe, you know, take a bike or a car or an airplane, go to the end of infinity to find out if these two lines are parallel. So we got a problem, because this is not a definition. This is a proof disguised as a definition. And this is the one that people, geometers, are still using today. So no, parallel lines are equidistant lines throughout the length, especially of the short one. I think I've got it here. Let me put it up here. Okay, that's the definition of a parallel line, whether they like it or not. That's what it means in physics. It means that two lines are equidistant. They have the same distance throughout what you have in front of you, because there are no infinite lines in physics, only in mathematics and so-called geometry. These people have infinite lines. In physics, there are no infinite lines, first. And second, what you have is really edges of the lines, because the lines are really two-dimensional. Okay? So we don't know of any one-dimensional line, but whoever knows of one should just bring it in or draw it or whatever. Okay? Okay. Here's the definition of line continued. What you have is, again, he says it's breathless length, and in proposition 12 of his book, Elements, he reinforces this notion by extending the line infinitely. He says to draw a straight line perpendicular to a given infinite straight line. And the problem with the infinite straight lines is that he uses that throughout his book. And again, this is all from the Greeks, right? And you'll see that they'll extend any line, like the line that forms the edge of that triangle. You know, they'll extend it because they're going to figure out some angles from the outside of the triangle. And in order to do so, they have to extend the line. And that's where the so-called infinite line, or the fact that a line segment is not a line, comes in, you know, that notion. They have to extend the line in order to figure out angles, okay? And yeah, as you can see, the line is two-dimensional. I don't know of any one-dimensional line, but again, if any of you know of one, I sure would like to see a one-dimensional line. Never saw one, okay? Let me know. And, well, he moves on to planes, okay? Planes, he calls them, or whoever, maybe it's a translator. Again, I don't want to accuse Euclid completely here, okay? But he says a surface is that which has length and breadth only. He's talking about a plane. Okay, so it should be a plane is that which has length and breadth only, okay? And again, it's not breadth, because they're pitting a dimension, length, against a vector, which is breadth. Okay, the three vectors, for purposes of physics, which you would think that's what geometry was trying to figure out here, the three vectors are depth, breadth, and elevation, because they're all motion. You're moving. It's a vector is a dynamic concept. Okay. On the other hand, dimension is a static one. You know, you just have three perpendicular lines to each other at 90 degrees. Okay. There's no motion in dimensions, but there is motion in vectors. And so these people, whoever, whether it was Euclid or a translator, someone goofed, because you cannot pit length against breadth. And that's where you get also these people pitting, you know, space against time. They put an arrow going up for time. And we'll get to that when I get to dimensions. But you can see what's happening here. Okay, he said the edges of surfaces are of a surface are lines, and a plane surface is a surface which lies evenly with the straight lines on itself. Exactly what the difference between the first definition, number 5 there, and definition 7, I have no idea. I've looked it up. I still can't figure out what the differences are. Okay, but let's look at the summary that I have against all this. Okay, I'll put it next to it here. Okay, these are the objections I have to Euclid's notions. First, the surface is 3D. The word surface does not belong in the 2D world of planes. Surface is 3D, plane is 2D, and that's why that word surface is wrong in his definition 5. And again, I don't know if it's him or the translator. Breadth is a vector, not a dimension. You cannot put, you cannot pit breadth against length or width or height. Edges are not lines. Okay, that's a long story. I'm not going to go over that right now. Lines are 2D. Okay, if you know a line that is 1D, let me know. Okay, draw it and send it to me. I'll publish it. I'll eat my words. A plane is not made of lines or points, because if it were made of lines and points, it would not be smooth. A plane is made of a single piece, and it's usually a piece of it's a piece of a solid. Square is one side of a cube. That's the notion of plane. Okay, and you see it head on, so it's got to be a perfect square. As soon as you tilt the cube, you no longer have a square. I mean, if you could get a perfect cube, right, an ideal cube, right, God's cube, okay, and you tilt it a little bit, now you got a rectangle. You no longer have a square. You can say, no, from another angle. No, now you have a square. All we have is the field of view. So you can't tilt these things. If you tilt a circle, you get an oval, and so on. And these people just tilt squares and ovals and just prod on without bothering, you know. And then the issue is how flat is flat. And you might say, well, how important is that? I mean, flatness is, flat is flat, like a flat table. No, that's not flat. Tables are not flat, okay? Flat is, if we're going to use the word consistently, we have to define it very precisely, okay? And flat means no thickness, okay? Let me show you an example here. Here you have the Flat Earth Society. I guess some of you heard of that, right? And one fellow there at the Flat Earth, this Flat Earth, because there are several Flat Earth Society and one denies the other guy, right? So this model states that there is an infinite plane of exotic matter somewhere below the disk, pushing in the opposite manner of traditional gravity. This is a recent theory and is in progress. They have this this plane. I drew it white, okay, and it just cuts the universe in half, and it's infinite, right? And so that means you can't see below this plane. Okay, so the Earth sits on this plane, I guess, in this flat plane. And so, yeah, you can't see below it. And so the question is, how do you know there's a plane there first, and how do you know it's flat? Well, how flat is the Earth? If these guys talk about the Flat Earth Society, how flat is flat? Have they ever defined the word flat? Or are they going to use some very loose notion for flatness? Okay, so no, you got to define the word flat perfectly exactly if you're going to be the Flat Earth Society, okay? And one thing they don't define is the word flat, and we don't need to define it mathematically either. We need it qualitative. We need to define it qualitatively, okay? Because we're going to talk about how the Earth is made, right? And so it's a qualitative issue. You can't go in there and say, well, it's zero whatever. No, yeah, you can say zero thickness. That's about it. But if you got zero thickness, you got nothing. And so zero thickness means nothing. That's what it means. Okay, so keep that in mind. You can't define it as zero thickness. Okay, you think the Flat Earthers are the only ones who have problems? No, here you have the relativists, okay? And what do? Well, they have this Dr. Quantum, he goes to Flatland. And you can see he sticks his finger through Flatland, and it's not flat, it's got a certain thickness. So again, how flat is flat? I mean, if Dr. Quantum can stick his finger through the thickness of Flatland, well, then Flatland is not so flat, okay? And again, so these people have problems with that. You might say, well, how important is that? Well, it turns out that they moved on from Abbott's Flatland, which was a 20th century book, 19th century book. And today we're talking about not the flat Earth, but the flat universe. This is what the relativists say. We have a flat universe. And here you have the bottom pictures from them. The upper one on the right is mine, but essentially mimics what they're saying. Okay, we got this WMAP study, and they say that's our universe. Well, I put it on a disk because they're saying it's supposed to be flat. So we have this roundish or spherical flat universe, however you interpret that, a spherical flat. Okay. Yeah, and it doesn't stop there. You can see these are the images that you'll see here and there. You'll see this is the block universe, and a cross section of that is time. And so our flat universe sits on that flat, it's like the cover of that cup, horizontal cup. Okay, so yeah, they're thinking about a flat universe of some kind. Who knows how they picture it? They never draw it. And here you have a picture of it from Astronomy magazine, okay? And this was, I think, 1999, yeah. And again, you can see this is what they draw. This is the universe they're proposing. And you're saying, well, what do you mean? Are they really saying this? These great scientists, these sages? Yeah, that's what they're saying here. Einstein's flat universe. Here it is. Look, I'm going to show it to you from the magazine. That's good old Stephen Hawking. Okay, and this is the universe he proposes, the one in the center. Okay, so yeah, that was printed in a magazine. This is the universe they propose. So you live in a flat universe. Forget about the Flat Earth Society. These guys are the Flat Universe Society, and that all comes from Aristotle and Euclid when they defined these terms for the purposes of geometry. Remember, relativity proposes that gravity is the geometry of space, and it's curved in our world. In the four-dimensional world, it's flat. So you try to understand that, see if you can make sense of it. And when you put them against the wall, they say, well, you got to take math to understand it. So we need to take Mother Nature needs to take math to understand her own universe. Think about that. Anyways, I'm going to continue with this and dimensions especially next time around. It's going to be Wednesday. If you're still in your homes, locked up, you can't go out other than to buy maybe food and drugs or whatever, well then you'll probably tune in. So we'll see you on Wednesday, and hopefully you don't catch the virus. Bye-bye.